Okay, so hello everyone. So this is the last class of electrochemistry. We have done already a tremendous work in terms of electrochemistry. That is we started with oxidation reduction, the simple thing, and then goes to Daniell cell, function of salt bead, electrode potential. After that, cell notations, and then elect the introduction of galvanic cell, EMF of the galvanic cell, and after that the big shot, that is Nernst equation, and then we have already done uh, what now the little bit thing we have done in between. Then we start the conductance of electrolytic solution, then molar conductance, equivalent conductance, and last thing we did in the last class, that is the variation of conductivity and conductance with dilution. Correct? Okay, so but we did not complete it. We have already discussed with the conductance of a solution with the change of conductance of a solution with dilution. Okay, so today we will start with the conductivity. So basically, what is conductivity? We all know that conductivity is essentially the conductance of a unit Q. Correct? That is basically the specific resistance. What is called the specific resistance is basically the resistance of a small Q. Correct? When the L equal to 1, A square equal to 1. So then, what is the resistance? That is essentially equal to your specific resistance. Okay, so there is conductance is same like that. Conductance, the specific resistance is the resistance of a cube, and conductivity is the conductance of a cube. Okay, so not a cube, conductivity of a solution, cubic solution. So if we write, that is conductivity is essentially equal to conductance of 1 centimeter cube. You can write 1 meter cube, basically 1 unit volume of a cube, correct, of solution. Okay, okay, so then think like that. So suppose you have a solution in a vessel. Okay, so suppose you have a solution in a vessel. Okay, okay, so then consider a cube in between this. So this one is a cube. Just try another color. Let me guess. Try another color. This one. Okay, so this one is a cube with 1 centimeter cube volume. Okay, so then the conductance in between this cube, that is equal to your conductivity. Okay, as simple as that. Okay, so then consider that dilute the solution. Okay, so if you dilute the solution, then essentially what happens now? Essentially, the number of ions. Okay, so conductance is essentially is proportional to the number of ions. If the number of ions in a solution increases, then the conductance of that particular solution increases. I repeat, that is conductance. Okay, so if the number of ions of a particular solution increases, then the conductance of that particular solution is also increases. Okay, you all know that. Okay, so after that, consider that if we consider that number of ions present in that particular orange cube is 100. Okay, if you consider that. Okay, so 100 is the conductance of that particular solution. Okay, so 100 is basically your conductivity also of that particular solution. Okay, so then basically if you dilute the solution after that, so then what happens, the volume of the solution will increase. Correct? If the volume of the solution will increase, not the number of ions in that particular solution. Correct? The number of ions is not increase with dilution, but the volume of the solution will increase. So that's why the ion density in that particular solution will decrease. Okay, so ion density of that particular solution will decrease. If ion density of that particular solution will decrease, then number of ions present in that particular cube will also decrease. Correct. So if you dilute the solution furthermore, then what happens? Now the volume of that particular solution will increase, but not the number of ions. That's why the number of ions present in that particular cube will decrease. Okay, will decrease if you dilute the solution. Okay, so that's why we can talk that the conductivity of a solution will decrease with increase in dilution. So if you dilute the solution further more and more, then the conductivity of that particular solution will decrease. Okay, so this is your result. What now? Decrease conductivity. What happens now? Conductivity decreases with increase in dilution. Please take a note on that. It is very important line for your upcoming exam, that decrease with increase in dilution. Okay, why? Now what is the reason behind that? I already told you. The reason behind that is number of ions number of ions per unit volume per unit volume sorry number of ions per unit volume decrease. Correct. Okay, so suppose before there is present in the cube 5 ions. Okay, so if you dilute it, okay, so if you dilute it, then after dilution there is present suppose 3. Okay, so that's why the conductivity of that particular solution will decrease with increase in dilution. Okay, okay, so just for a recapitulation, that conductance will increase on dilution, conductance will increase on dilution, but conductivity is decreased with on dilution. Okay, please take a note of that. Conductance increases on dilution, but conductivity decreases with increase in dilution. Okay, so this is the portion of the variation of conductance and conductivity with dilution. Okay, so please try to remember these two logic behind that. Okay.